Hello there, part 2, week 6 lecture. So the agenda now is we're going to look at shearing stress. So we're going to look at shearing stress now. So shearing stress or shear stress are stresses acting parallel to the surface. Okay, and there are only two possible or two configuration in shear stresses. Okay, so what are the two? So we have so one of the configuration. Okay, I'm going to draw the element. Okay, so on this side, I'm going to call it a positive shear. Okay, on the other side is negative shear. Okay, so positive shear and negative shear. So let's look at the shear stress. So over here, so again, transformation to follow x and y. Okay, so the shear stress is drawn in this manner. Okay, so this is a positive shear configuration, and the other side is a negative shear configuration, and I hope you see the difference. Okay, so one is known as positive shear, the other one is known as negative. So this arrow represents shear on the x plane, y direction, whereas over here it shows the shear on the y plane, x direction. Okay, so likewise, if I go the other side, this is the shear on the x plane, y direction, and this is a shear on the y plane, x direction. So the first subscript over here, so this is the plane, and this, and the next one over here, the y over here is the arrow direction. Okay, so for this case, so if I'm going to call them in plane, so this is my this surface will be my positive x plane, right? If at the center over here is my 0, okay, likewise the center over here is my 0, okay, and then on the other side is your negative x plane, and then over here on the top, I'm going to use the other side. This is your y. Okay, so this is your positive y plane, and then over here is your y negative, right, y plane surface. Okay, and if you look at this arrow, alright, you look at the arrow is going to have y positive and this is x positive, okay, and likewise this is x negative, this will be y negative. Okay, so if you look at, and if I'm going to draw the other side over here, this is your x negative, this will be your y positive, this will be your x negative, and this will be your sorry, that will be your y negative, and this will be your x positive. Okay, so if you look on this surface over here, okay, so what you'll see is y positive and x plane is also positive. Okay, and then if you look at over here, you have x positive is acting on a positive y plane. You can see that now, right? So likewise you have negative y direction on a negative plane, and you have a x negative on a y negative plane. So basically positive multiplied by, so positive multiplied by positive, the answer is positive. Negative multiplied by negative, the answer is negative. So for this is positive shear because you have a force as y direction positive, and then you also have a plane that in x plane, acting on x plane, that is also positive. So positive, so that's why this is positive shear. On the other side, you can see you have a negative plane, x plane, and the force or the stress is going negative. So negative negative also becomes what? Positive. I do apologize, this is also positive. So this is why it's positive shear. Whereas for this case, just an example, you have a positive plane and negative what? Force acting. So positive and negative, or negative positive, both will be what? Negative. So that's why on the left hand side is not positive shear, on the right hand side is negative shear. The next thing I'm going to draw is also how the elements will be deformed. So how the element will deform, if you look at the arrow, okay, and you squeeze the arrow up, okay, you compress the arrow, this is how the element will deform. Okay, the element will deform this way. Okay, if you squeeze the element, okay, the element will deform this way. So positive shear have the tendency to deform in this direction. Okay, so this is how the element will deform. Okay, so this is for positive shear. This is how the element deform. Do apologize. So this is positive shear, this is how the element will deform. And then on negative shear, I'm going to use a different color. Negative shear, if you based on this arrow, okay, you physically squeeze the element, right? How the element will deform? It will deform this way. So this is for, so there's the difference between positive and negative shear, how the elements are deformed. Okay, and by no means there's no relationship to say that which is a better shear. Okay, does not mean positive shear is better, negative shear is worse. No, there's no such relationship. Okay, so this is the deformation pattern. So likewise on the other side, this is also the deformation pattern. Okay, then I'd like to highlight not possible cases in shear. Okay, we are going to look at not possible cases in shear. Okay, and this shall and will never happen. So if you have an element, right, so you have an element over here, and then there's a, I'm going to copy, and there's another element. So in shear, this is an impossible configuration, you cannot have your shear stress acting this way. Okay, it cannot act this way, or neither can it act this way. Okay, so you cannot draw based on your element, so not possible. So your element will just rotate. If it rotates, means there's no stress, or you cannot have element stresses going this way also. Or if you're going to draw, you cannot. There's no reason. So these are not possible. Okay. So I'm going to draw the other side again. So these are the case that's not possible. Okay, so you cannot draw it doing this sort of configuration at all. Okay, so it just basically tell you that the elements are rotating, so not possible. Okay, now the next thing I'm going to do is how are we going to relate the element to Mohr circle. Okay, so I'm going to deal with positive shear first. Okay, I'm going to do positive shear. So I'm just going to have an element okay, so the element on positive shear, so this is the direction. Okay, so this is positive shear, right? So it's always a known fact. So this is shear xy, and this is shear yx. So it's always a known fact that shear yx or shear xy is equal to shear yx. And then if we put a pivot point over here, okay, the element is free to what? Is free to rotate. Okay, the element is free to rotate. So I'm going to call this surface over here my x point, and this surface and my y point. And what we realize over here on this example, where stress x is equal to stress y, and both are equal to 0. Okay, so that's the element. So now coming back on Mohr circle, now bring it back to Mohr circle. So on the x-axis, we know this already. Okay, on the x-axis is our normal stress, and then on our y-axis is our shear stress. Right. So this is normal stress, and this is our shear in a clockwise direction, anti-clockwise direction. Okay, so we know that point x and point y will lie on the 0 point over here. Okay, so point x and point y, so both of them will be on the center line, because normal stress is equal to what? 0. Okay, now where is point x now? So let's focus on it. If you look at point x, okay, if you look at point x over here, I'm just going to use a slightly different color now. If you look at point x over here, this force shear xy, or the arrow, is going to generate the element rotation about anti-clockwise about the pivot point O over here, about our pivot point. So it's going to rotate in a what? In a clockwise direction. Sorry, and anti-clockwise direction. So if you look at your arrow configuration, anti-clockwise over here means over here, this is where our point x is. Okay, because the element that the shear xy, this arrow will generate a what? A anti-clockwise rotation. Now let's look at point y. So if you look at point y, right, based on this configuration of the arrow going down here, right, it will generate a what? A clockwise rotation about a pivot point O. So it's going to come out clockwise direction. So this is clockwise direction. So what you realize at point y point Y is going to be located somewhere around here. So this is your point Y. So from here you have 2 points. You can construct Mohr circle because our normal stress is equal to what? 0. Okay, so this is point A. So it has the location of point X on point Y is dependent. So what we learn down here, an important thing to note is the location of X and Y, right, on shear is dependent on the rotation of the element. Okay, only, and not due to positive or negative, right? Nothing to do positive or negative shear magnitude. Okay, then let's construct negative shear. Okay, to let you see how does this look like in negative shear configuration. So on negative shear, okay, so I'm going to draw my element. Okay, so this is our element again. So negative shear, right? So this is shear XY, shear YX. So this is our negative shear. And then we will again rotate about a pivot. So I'm going to call this our point X. And then this is our Y. Okay. Again, once again, shear XY is equal to shear YX. Stress X is equal to stress Y. For this case, is equal to 0. Then we go on to Mohr circle now. Okay, we go into Mohr circle now. Alright, we know that this is our normal stress. And then the next one, this is our vertical axis shear stress on Mohr circle domain. This is our shear. Okay, and this is clockwise rotation, anti-clockwise rotation. So let's focus on point X. Okay, point X. Okay, and then when you look at this arrow over here, if you fix at the pivot point, the center, this arrow will generate a what? A rotation on that pivot point that is clockwise direction. So this is where your point X is. Then likewise, if you go the other side, if you look at Y, this arrow over here will generate a anti-clockwise rotation about the pivot point. So anti-clockwise. So this is our point Y. Then you can construct again. You can construct your Mohr circle. Okay. So this is the basic rules of Mohr circle. I will come back and we will start doing a few examples.